Hi, in this second video on circle theorems we're going to explore the remaining ones that I didn't cover in the last video on circle theorems 1 and give you some exam practice. Just like last time, there's going to be opportunities for you to take revision notes throughout the video, an exam question at the end, and also check on the YouTube page under the comments, because I'm going to put a link as well for some extra questions on circle theorems where you can download a worksheet with a load of extra ones, because these are the sorts of things that you just have to keep practicing and see lots of different examples. Okay, let's keep going then. So in this video I'm going to show you the rest of the ones that I didn't cover last time. They are alternate segment theorem, cyclic quadrilaterals, another one that it's not necessarily a circle theorem as such, but I'm going to include it. I'll show you that as we go on. As ever, I want you to take revision notes throughout the video, and at the end there's going to be a link to the extra practice questions. Okay. So the first one I said I was going to have a look at then is the alternate segment theorem. What it says is that the angle between a tangent and a chord through the point of contact is equal to the angle subtended by that chord in the alternate segment. Now, you don't need to remember all of that information. What you need to do is spot the required parts and write down alternate segment theorem. That's enough. So these angles are equal because alternate segment theorem. That's plenty for you to get the marks. So what you're looking for is a triangle shape that's inscribed in a circle, so it touches the circle on the corners. Okay, so we've got something like this. We've also got a tangent, and the tangent, the circle, and the base of the triangle all meet at a single point. If that's the case, then as we can see on this picture, this angle here, x, is equal to the angle up here in the triangle, x. I like to think of them as kind of being opposite to each other, as opposed to kind of like the Z shape that you might get here. Okay, so I'm thinking that they're kind of opposite. This Y angle here is opposite the other Y angle over here, and therefore they are the same. And just as a quick kind of note, these would share a common angle here, Z. Now, you know that angles in a triangle add up to 180. So x plus y plus z would add up to 180. Equally, angles on a straight line around here also add up to 180. X plus y plus z adds up to 180 again. So there's a little bit of a proof here for you as well. Although it's not particularly rigorous, and I've not written anything down, this is the way that we could prove that these two and these two are in fact equal. Okay, let's have a look on the right hand side of the screen now, where it says find the missing angles below, giving reasons in each case. I'm going to start off by looking at angle x. So x, I can see, is in fact one of these opposite ones here. It's opposite the 45 degree. So we can straight away jump in and say, yeah, x is 45 degrees. Reason why? Because alternate segment theorem. Alternate segment theorem. That's enough in your exam to get the full marks. Y is, again, opposite that, 60 degrees. Same reason, because of the alternate segment theorem. Finally, angle Z is the one like I was showing you just on the other side. You can do it in two different ways. You can either say angles in a triangle add up to 180, or angles on a straight line is your reason, whichever you prefer. But we've got 45 and 60, which makes 105. That must mean that Z has to be 75. So Z equals 75 degrees, and I'm going to say angles on a straight line add to 180 degrees. Okay, perfect. Right, so the alternate segment theorem. What you're with this is a circle with a triangle inside it, and the triangle is going to sit on some sort of tangent. If that's the case, then the angle here is going to be equal to the angle up here. The angle down here equals the angle up on this side, and the final angle is the shared one, okay, which would make them add up to 180 degrees. There's more than likely going to be other lines obscuring the view here, so there might be other things going on to make it more complicated, but try and pick through the other kind of rubbish that you might see on there and see if you can find this triangle and a tangent here for the alternate segment theorem. Okay, let's keep going. Next one, these are very rarely just going to be shown like this. You're not in an exam situation. I'll be very surprised if you just saw a four-sided shape within a circle. If you do, fantastic. Now, this is one of the few ones where the angles aren't equal. Okay, in this case, what it's saying is that opposite angles add up to 180 degrees. So the x and the z add to 180, and the y and the w add to 180. Okay, so they're called supplementary angles because they add to 180. It says the opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. Okay, so this is what we're looking for. Similarly over here, doesn't really matter where they are, they're still opposite. S and Q would add up to 180. P and R would add up to 180. Again, draw yourself out a little picture. Draw yourself some sort of quadrilateral. A cyclic quadrilateral just means a quadrilateral within a circle. Now again, mine are not particularly neat. However, yours, I'm sure, will be much better. What you can say is that the two red dots add to 180 degrees because they're opposite. And again, you can do with some blue dots or whatever colour you prefer. These add to 180 degrees. So be looking out for these. They are going to be hidden amongst other lines. Okay, so this is what you're looking for. Right, last one. I said I was going to show you something which it's kind of obvious, but I wanted to sort of point it out really. It says a line drawn perpendicular to a chord. So here's my chord, here's my line drawn that's perpendicular to it. It passes through the centre. It says it bisects the chord. It just means that this length here is going to be equal to this length here. Now, from there, you might be asked to work some things out like this. Here I've said find the length OS, so from O to S. Okay, now by knowing that this here bisects, straight away we can say, well, this must be 4 centimetres and this must be 4 centimetres. I've got myself a right angle triangle which has a height of 3 centimetres, a base of 4 centimetres. To work out the length OS, I can use Pythagoras, and I would end up getting 3 squared plus 4 squared, which is going to give me 9 plus 16, 25. Remember to square root that, so OS equals the square root of 25, which is 5 centimetres. I've got one of my standard 3, 4, 5 triangles. Okay, so again we're using a little bit of other maths thrown in here. We thought we were doing circle theorems, but it turned out we were doing Pythagoras. Okay, this is where you're going to get your top end marks. This is what turns these questions into an A-star question. It's just that combination of things that you can be required to do. Right, finally then, these are the last few notes that I've put. I've said don't forget that circle theorem questions might also draw upon other skills. For example, angles in a triangle, angles on parallel lines, Pythagoras. You might even be asked to do some trigonometry on there. It might be your SOHCAHTOA trigonometry, it might be sine rule, cosine rule, it could be anything. So just look out for these different things. There might also be angles in quadrilaterals, all sorts of angle facts thrown in to these circle theorem questions just to get those extra marks. You can't always just write down the numbers. In fact, more often than not, you've got to write down the angle and give a reason why. So think carefully about these. Okay, finally then, here's a question for you to have a go at. I want you to pause the video, see if you can work out what these are. I want you to see if you can work out angles SUT So that's from S to U to T. So that's this angle here, SUT. SOT, S to O to T. So again, it's the middle letter, it's this angle here. OTS, OTS. Again, the middle angle, so it's this little bit down here. And finally, OST, OST here. And I want reasons for each angle. Okay, so pause the video, have a go. Right, let's have a look then. So SUT, that's S to U to T. So that's the angle up here. Now, if I were to ignore the fact that I've also got these lines coming from S to O and T, I've actually got a triangle sitting on a tangent. SUT is opposite this 65 degrees here, so I'm happy that that's 65 degrees. Reason why, alternate segment theorem. Alternate segment theorem. Okay, next one, SOT. SOT. Right, well, let's see what we can do here. SOT. Well, I've just worked out that this angle up here is 65 degrees. Again, I'm going to colour this in so maybe we can see. Thinking back to a previous video, to Circle Theorems 1, we've got this delta shape, this kind of Star Trek sign shape. And we remember that the angle at the circumference is half the angle at the centre. So SOT is going to be 130 degrees. The reason being angle at centre is double the angle at the circumference. Okay, let's keep going. OTS. OTS. Let's see if we can just get rid of some of this. Tidy it up a little bit. Okay, so OTS. OTS. Well, let's think about what we know about this triangle. From O down to T and O down to S, these are both radiuses or radii. They're the same length. Now, if that's the case, I've got myself an isosceles triangle. I've just worked out what the angle at the top is. It's 130. That must mean that these two base angles are going to be equal. They've both got to be, well, angles in a triangle add up to 180, so both of these together would have to add to 50. That means that each of them must be 25 degrees. And actually the last one it's also said was OST. That's that angle here, so OST also equals 25 degrees. And the reason I would give is because of isosceles, due to the radiuses that were just marked on. Right, okay, last one. So this is the final one that I'm going to go through. Have a look at this one. This is an exam style question. Again, a little bit more tricky. So it says PR and PQ. So PR and PQ are tangents to the circle. U, this point U, is where the line meets. We've got all kinds of lines meeting at U. Find the missing angles, giving reasons. Again, I want you to pause the video, have a go, and then I'll go through it. Okay, so the first one. I think this was a little bit tricky. It took me a little while, to, I'll be honest, to spot what was going on here. But actually, what we've got is a cyclic quadrilateral. Here it is, I've highlighted it. Opposite angles add up to 180. So I've got 110 plus 48, which is 158. So W must be the extra component that adds it up to 180. So W equals 22 degrees. Reason, cyclic quadrilateral. Okay, X, angle X. Let's see what we can find out about angle X. Well, remembering that we know angle W now as well. So angle X, oh, here we go. So can you see straight away down here, we've got a tangent, meets at a radius. So we know that this entire angle must be 90 degrees. We know that W is 22. That must mean that X has got to be 68 degrees. Reason, well, we've got a radius and a tangent. Again, I'm putting these down as shorthand. I want you to write these out properly in an exam situation. So you would say that a radius and a tangent meet at 90 degrees. Okay, let's have a look for y now then. So again, let's get rid of this. Let's keep it nice and clear. Remembering that we also now know w and x, so it might be useful for us. One of our circle theorems stated that two tangents to the circles meet at a point the lengths are the same. These two are the same. I've got an isosceles triangle. Here it is. Just going to colour it in blue so we can see it. So here's my isosceles triangle. I know the base angle x is 68. That must mean that this angle over here is also 68 degrees. And 68. So now I can work out y. So I've got 68 plus 68, which gives me 136. That must mean that y has to be 44 degrees. And the reason, isosceles triangle. Okay, finally, the last one that we've got is Z. And actually, I'm going to leave the drawing in this time. If you were to turn your paper around or turn your screen around, even without, you might see that here, Z, I've got a triangle sitting on a tangent here. You can see that these are opposite each other. This is your alternate segment theorem again. So Z also equals 68 degrees, reason being alternate segment theorem. Brilliant. Okay, so have a look on the comment section. There's extra circle theorem questions for you to have a go at. Download those, have a go, bring them into me if you come to Tupton Hall. I'll happily go through them with you. As ever, good luck with your exams. Fingers crossed you do well. Keep watching the videos. If you subscribe, you'll get links to the videos straight away. You get notification rather than me having to tweet them out. But I am going to start tweeting using the @TuptonMaths account. So if you're not currently a follower of that, I'd make sure I was doing that too. Okay, good luck. Bye.